Today we're going to talk about powers of our trig function, and that's just making sure that you understand the notation and keep straight what they're talking about. It's not anything hard, it's just making sure you use the new notation correctly. And then we're also going to find the equation for a line that is the perpendicular bisector of some other line segment. Not as hard as the name sounds, trust me. So first, trig powers. If you see any trig function and then you see a square right on the trig function and then the angle, that simply means, in this case it was sine of theta times the sine of theta. Get your ratio off the unit circle or out of the calculator or whatever it may be, and then multiply it by itself or cube it or whatever your power might be. The thing to be careful of, it is not the sine of theta squared. It's not okay to move that exponent so that it's on theta instead of on sine. This is not the sine of theta times theta. So let's just do a few examples of what that means. All you really need in your notes is what this means up here. So if we have the sine cubed of negative 60 degrees, that means we need to figure out what is the sine of negative 60, and then take that number times itself 3 times. So negative 60 degrees, we're going down. That would put us down here. Sine in that quadrant, is it positive or negative? It's negative, it's the y, we went down, so that's a negative something. We've gone down almost as far as we go, so what's the value from our unit circle? Sine, we've gone almost all the way down, negative root 3 over 2. So negative times negative times negative is a negative, so we know we have negative something. Denominator is probably easier. 2 times 2 times 2 is 8. Numerator, root 3, root 3, root 3. 2 root 3's go together to make a regular 3, and then we have one more root 3 left over. So negative 3 root 3 over 8 is our answer, and that's how we evaluate that one. Okay, let's do several of these because it just takes practice to get them. Okay, when we have our reciprocal trig functions, have to be careful, and please write every little thing down. Right now, this is new for you guys. Don't try to combine steps as mental math, because since this is new, your brains start making mistakes on it. So write out the little steps along the way. It pays off in the long run for you guys. Cotangent is either 1 over what? 1 over the tangent of our angle, or it is cosine over sine. And we use the second one if we're in a place where tangent is undefined, if we're at the top or bottom of the unit circle. So let's figure out where we are with 330 degrees. So this time we're going in the positive direction. So we're still in the 4th quadrant, right? But we're pretty close to the x-axis. So we're not at the top or the bottom. So we're going to do the 1 over tangent for this one, because we're somewhere that tangent is defined. So write that down, and you can't just do 1 over the tangent squared. You've got to have the angle in there. It's meaningless to just say tangent. You can do that in scratch work, but when you're actually doing it for your problem, include the angle in there. So that is 1 over whatever our number is going to be squared. Do you remember, is tangent positive or negative in that quadrant? It's going to be negative. Tangent is positive in these two, negative in these two. So that's 1 over a negative something. Negative how much when we're just that first spot below the axis? What's our tangent value on our tangent circle? Square root of 3 over 3. Okay, then we have 1 over, so we're talking reciprocal. So before we try to square anything, let's flip our fraction, and we have negative 3 over root 3 that we need to square. Negative negative is positive. 3 times 3 is root 3 is, reduce it, and we have 3. Next, cosecant. Cosecant is 1 over what? So we're going to write that down first. So that's going to be 1 over the sine of pi over 3. And then we need to square that. So that means, let's see, pi over 3, we're going in the positive direction. So we're here. Sine positive or negative? Positive. We're almost as high as we get. So positive what? So I keep my 1, my sign goes just in the denominator, positive root 3 over 2. And then I need to square that. 1 over means I'm taking the reciprocal, so flip it. 2 over root 3. Square that. 2 times 2 is 4. Root 3 is 3, and we have 4/3. Thumbs up, thumbs down. How are we doing with this? Okay, one last one, and then we'll move on to those lines that we need to find for our second topic. So this time, secant is 1 over cosine. So I'm looking at 1 over the cosine of negative 2 pi over 3. And once I have that, I need to cube it. So minus 2 pi over 3, I'm going down. That will put me here in the third quadrant. Cosine, x or y? Cosine's the x. When I go to the left, is that a positive or a negative x? So I've got 1 over negative something. I haven't gone very far past 0, so Dylan, negative how much? So negative 1/2. Inside the parentheses, I have a reciprocal, so flip it, and I have negative 2 over 1, or negative 2. Cube that, and I have negative 8. So questions from anybody on that? Okay, then let's move to that other topic, finding equations of perpendicular bisector lines. So a little bit of review. If we're talking about a perpendicular bisector, we're going to be doing the equation for a line that's perpendicular. And we need to remember that perpendicular slopes are negative reciprocals. So if one is A over B, the other one is the opposite of B over A. So remember that. The other thing we need to remember is that bisect means cut it into 2 equal pieces. So if we are taking a line segment and getting the perpendicular bisector, it needs to cut that into 2 equal pieces, which means it goes through the midpoint. You are going to start seeing problems that say find the equation of the perpendicular bisector of the line segment whose endpoints are 4, 2, and 8, negative 3. So maybe I start off with 4, 2, and 8, negative 3. And it says the segment whose endpoints are those. So I drew a segment that went between there. A line does not have a midpoint because if it goes forever, you don't know where the middle is. You've got to know where it stops and starts to be able to know where the middle is on that. So then I need to have that midpoint, and then I'm trying to get this perpendicular line, and that's what I want to end up with as an equation for the red line. So I got the idea of what they're asking us. Okay, so here's what we're going to do. Since we know that it goes through the midpoint, our first step is, hey, let's find the midpoint. Let's find the point that is on that red line. So to do that, we are going to take the average x, comma, the average y. So I do parentheses. I do average x, 4 plus 8 over 2, comma, average y, 2 plus the negative 3 over 2. And I get 12 over 2 is 6, negative a half. That is my midpoint. The midpoint is on the line I actually want. So it needs to make the equation that I end up with true. You with me on that? Okay, to get the equation of the line, I've got a point on the line, but I also need the slope of that red line. So to get the slope of the red line, I first get the slope of the blue line, I get the slope of the segment, and then I get the perpendicular slope. Because the line I really want has that perpendicular slope. So to get the slope of the line segment that I started with, I have to subtract the y's. So 2 minus the negative 3 over 4 minus the 8 gives me 5 over negative 4, or negative 4/5. That means the slope I really want is, flip it and change whether it's positive or negative. So I really want 4/5. So the line I really want has slope 4/5, and the line I really want goes through the point 6, negative a half. So now I just need to put that together and get my equation. And that is going to be my final step on here, is to use the midpoint and that perpendicular slope to get the equation, and then put it in whatever form they say in the problem. Double intercept, slope intercept, whatever they want. Now, let's be a little bit careful, because here's the mistake that I see students make a lot. I see students say, oh, 6, negative a half, I don't like fractions, I'm going to use one of the other points. That does not work. If you use this point 4,2 and the perpendicular slope, you would get that line. That's been shifted from the line I really want. So I can't use that. These two are not on the line I want. So I can't use them. My only choice of which one is the midpoint. So to have our final equation, we are simply going to say y equals mx plus b, use the perpendicular slope, put in the point that we know is on the line, use the midpoint, even if it's messy, 4/5 times 6 plus the b is negative a half. Okay, so that's 24/5 plus b. So it looks like I need to subtract 24/5 on both sides. But to do that, I need a common denominator. So let's see, I need 10 for my common denominator to be able to do minus a half minus 24/5. So what do I have here? Negative 5/10 minus 48/10, negative 53/10. I get that right? Okay, so what if it's messy? My equation is y equals 4/5 x minus 53/10. And I got to check correct format. I don't remember what the problem said. So I turn back in the book and read it again. Am I done or not? Slope intercept. Slope is m, intercept is b. Do I have the formula with m and b? So I have the right one. I don't have to do any of that double intercept stuff. I don't have to get rid of all the fractions or anything like that. I'm done. So questions from anybody on that? Now let me point out one last thing about this. Come back up here to my picture. This problem asked me to find the red line, right? And it went through the midpoint between those two first points at 90 degrees. Now, is this midpoint the same distance between my two original points? That's definition of midpoint, right? What about this point on my red line? Is its distance to the first point going to be the same as its distance to the second point? What about this point over here? What about any point on my red line? Is it equidistant to the two original points? That sounds an awful lot like the kind of lines we've been finding already. The line that is equidistant between 2 points is the same as the line that is the perpendicular bisector of the segment between those 2 points. So you need to read these problems carefully. And I've written over here on the regular board so I can leave it up there for a few days. If they just say, find the line that's equidistant between these 2 points, pick your method. If they just say, find the perpendicular bisector of the segment that goes between these 2 points, pick your method. But if they say use one method or another, you've got to do what they say. Now, they could try to trip you up. They could say use the locus definition method. That's what we've been doing for weeks now. Use the locus definition method to find the line that's equidistant. Or they could say use the locus definition method to find the perpendicular bisector. They could describe it this new way, but still want you to do the square root equals square root method. All that matters is which method they say use this method. It does not matter how they describe the line. They could say use the midpoint method to find the line equidistant or to find the perpendicular bisector. That means find the midpoint, parentheses and comma, find the regular slope, flip it upside down and put a minus sign in front of it, and then get that line. So questions on that? I just wanted to give you guys that caution and point out that they're the same thing.